Hello dear students. In this session we are going to solve the numerical on conjugate beam method. In this question we are given with a cantilever of length 3 meter carries a point load of 10 kilonewton at a distance of 2 meter from the fixed end. If E is given to us, I is given to us, find the slope and deflection at the free end using conjugate beam method. So in this question, we have to use conjugate beam method. Cantilever beam is there. Now the cantilever beam is there. The length of the beam is 3 meters. It carries a point load 10 kilonewton at a distance of 2 meters from the fixed end. From the fixed end, there is a point load of 2 meters. E is given to us, I is given to us. We have to find the slope and deflection at the free end and use the conjugate beam method. So let us solve this problem. In this question we have to find out the slope and deflection of this cantilever beam at the free end, where this is loaded with a point load 10 kilonewton which is at 1 meter from the free end. We have to find out the slope and deflection using conjugate beam method. We have to use the conjugate beam method. So how to find out the slope and deflection? First we have to, what is conjugate beam? The conjugate beam is a beam which is loaded with a bending moment diagram of width EI, and the width of the beam is EI. That is the conjugate beam, right? And also for cantilever beam, the free end becomes fixed end in a conjugate beam, and the fixed end becomes free end in conjugate beam, right? You have to remember this also. So first we have to draw the bending moment diagram. That bending moment diagram will become the load for the conjugate beam, and then we can find out the slope and deflection at the point B, right? So first of all, draw the bending moment diagram. So how to draw the bending moment diagram for this beam? Suppose this is the point A, B, right? And we have to draw the bending moment diagram. Now for bending moment diagram we have to take the section. As usual we are taking the section. So at a distance x, from the free end, let us take a section. We have taken a section x, right? So what is bending moment at x? And it will be valid between C to B. So mx, which is valid between C to B. CB I am writing, it means it is valid between C to B. So that will be equal to, is there any load? Is there any load between C to B? There is no load. So it is 0 because there is no load. So MCB is equal to 0. It means, and the entire C to B, it is 0. You can find out MB at x is equal to 0. This is 0. And MC at x is equal to 1 meter. This is 0. So it is 0 and entire section of the beam up to from B to C. So from B to C, this is a straight line with 0 bending moment. So I am making it slightly darker, which shows that this is a 0 bending moment between B to C. Next, we have to find out bending moment between, and we have to take the section between C to A. So let us take a section between C to A. Let us take section here, and the section name is again suppose x, right? So we are taking again mx, which is valid between C to A. It is valid between C to A, and that will be equal to the load. Load is 10 kilonewton and it is negative. Moment of 10 kilonewton is, we have taken x from the extreme edge, extreme free edge. So this is x minus 1. So 10 multiplied by x minus 1. We could take x from 10 also, but we have taken x from the free end, the bending moment. So it will be 10x minus 1. It is valid between C to A. So at C point, MC, at C point, x is 1 meter. You will get 0 bending moment. And at A point, where x is 3 meters, the bending moment is 20. This is minus. This is minus actually. Minus 20 kilonewton meter. So from 0 to 20 with a linear variation. So we are getting from 0 to 20. This is 20. Suppose this is 20. From 0 to 20 between A to C, right? So this is a linear variation. This is a straight line. right? And this is 20 kilonewton meter. So this is the bending moment diagram. This is the bending moment diagram for this beam, right? Bending moment diagram. Now this will become a conjugate beam. Now this will become load of the conjugate beam, and it is negative, but because we have to find out the slope in magnitude, so you can take negative and positive will become immaterial. So now this bending moment diagram will become the load of the conjugate beam. So if I draw a conjugate beam now here, if I show a conjugate beam of this load only, this load, this is a conjugate beam like this, right? This is 2 meters and this is 3 meters, right? This is 2 meters, this is 1 meter, total is 3 meters, and this is 20 by EI, right? I am taking 20 by EI directly. Later on we can add later on also, but I am adding here only in divided by numerator EI. Now, and the total load is area of the diagram, area of this triangle, and area of the triangle will be acting at certain point G, suppose, and it will be acting at certain point this, right? This is the load P, right? And this end will become now fixed end, this end will become fixed, this is now fixed, and this become free, right? And this is the load now, right? And it is although negative, but I am showing it positive because we have to find out the magnitude, so there is no problem in that. So I am showing this. This is the load which is applied on, and this is now the conjugate beam. This is now the conjugate beam, right? And what is this distance? This distance, suppose x bar, and what is this load? So this load P will be equal to load P, which is the conjugate beam load, that will be equal to area of this triangle, that is half, multiplied by base multiplied by height, 20 by EI. So this will be equal to 20 by EI. And what is the unit? This is the unit will be, upper unit will be, this is kilonewton meter, right? So, and multiplied by meter, because this is meter. So this is kilonewton meter square divided by EI, whatever the unit of EI. The numerator has a unit of kilonewton meter square, and EI, whatever is the unit of EI. Now, and what is x bar? This x bar, distance of this. So this is 1 plus 2/3 of this 2 meters, right? So this will be 1 plus 2/3, because this is acting 2/3 from the apex, right? So this is 2/3. So 2/3 of the 2 meters, right? So 2 meters. This will be equal to 1 plus 4 by 3. So this will be equal to 7 by 3 meters. So this is x bar, 7 by 3 meters. So x bar is 7 by 3 meters, load is 20 by EI, and we have to find out the slope and deflection at the point B. So at point B, now this is suppose A dash, this is B dash, and this is C dash. So at point B, slope at point B will be equal to the shear force of conjugate beam at point B. Shear force of this conjugate beam at point B. So what is shear force? That is the load of this body, that is a load about A, right, about B. So you can take a section from this point and take the section and find out the shear force. So this will be load only, right? So theta B will be equal to P only, right? And that will be equal to, and P is 20 by EI, and if we want to find out mathematically, that is 20 multiplied by kilo 1000 meter square, so 10 power 6, this is millimeter square. E is given to us, that is 2 into 10 power 5 millimeter Newton per millimeter square, and that is 10 power 8 millimeter power 4. So the answer will come in radians. Solve it and you will get the answer in radians. So theta B in radians will come out to be 0.001 radians, 0.001 radians. So this is the answer. This is one of the answer, the slope at the free end. Now we want to find out the deflection at free end. So deflection at free end will be the bending moment at point B, bending moment of conjugate beam at point B, bending moment of conjugate beam at point B. So that will be equal to this load multiplied by x bar, load multiplied by x bar. This is the moment, bending moment, right? Load multiplied by x bar is the bending moment, right? So no other force is there, only this concentrated load is there, load of this triangle which is acting at point G. So that will be equal to P x bar. And what is P? This is 20 by EI multiplied by x bar. X bar is 7 by 3. So this will be equal to 210 140 by 3 EI. And solve it, you will get the answer 140 multiplied by, the unit is kilonewton meter square, meter is again multiplied, so kilonewton meter cube, so kilo meter cube is 10 power 9 divided by millimeter cube divided by 3. E is given to us 2 into 10 power 5 and I is 10 power 8. You will get the value of the deflection at point B, and the deflection at point B will be equal to 2.33 millimeter. So this is the answer of this question, right? So this is how we can find out the slope and deflection of any beam using conjugate beam method.